Okay, so hey ladies and gentlemen, this is Miss Humbert and we're going to start our very first note sheet of Unit 3, which is just talking about triangles. So today we're going to just go through all the different names we have for triangles. So similar to last unit, it's going to be a lot of definitions at once, but it's really important that you have that written down on your note sheet so that you can reference it and help it to study, because we're going to be using these for the rest of the unit. So let's go ahead and let's take a look at this first box. So to name a triangle, the first thing we do is write the triangle itself. And then we name it by its vertices. And so a triangle always has 3 vertices. That are these points right here. So this triangle I would name A, B, C. Typically I put my letters in alphabetical order, but the order really doesn't matter as long as you have the triangle out front and you have all of the vertices included. So to name a side, this is just like when we would name line segments. So we have line segment AB, and we also have line segment BC. So we're showing it's a line segment by putting a line over the top. And lastly, CA. It doesn't matter the order in which you write your letters as long as you have all of them written down. So now we're going to name an angle. So let's start by taking a look at this angle right here. Well, when you're naming that angle, we're going to call that angle BAC. So when you're naming angles, if you're going to use every single point on the angle BAC, the middle letter needs to be the vertex of the angle, that elbow. But BAC, you could also just do shorthand and name it just by its vertex and call that angle A. Likewise, if we were then to take this angle right here, we would call that angle BCA, or we could also just call it by its vertex, which would be angle C. Last but not least, we could also look at angle ABC. Or we could just name it by its middle or angle or vertice, which would just be angle B. So you can just name it by the vertice, but you will see some where it has all 3 of them written. So let's take a look at this type of triangle. So this type of triangle is acute. Okay, and I like to look at it as it's a acute angle. All of the acute triangle, because all of the angles are small. They're cute. So in an acute triangle, we have 3 acute angles. So every angle in the triangle is less than 90 degrees. Maybe write that down. So every single angle is less than 90 degrees. For this one, all of our angles are going to be the same. If all our angles are same, then we have an equiangular. So all that means is equal angles. So equiangular triangle. And that means we have 3, and they're going to be congruent. And they're also going to be acute, because in order for them to be congruent, they have to be acute. Taking a look at this next angle, if you notice, this next one has a big angle. Okay, so this would then be obtuse. It's an obtuse triangle because it has one angle that's obtuse. So it has one obtuse angle. It's not possible for a triangle to have more than one obtuse angle. Now remember that obtuse angles are greater than 90 degrees. So this triangle is going to have a little square in the right corner. Remember that little square means that it's right. It's a right angle. And that also means that its measure is 90 degrees. Okay, so we're going to call this a right triangle. And there's one right angle. Okay, so it's a right triangle and there's one right angle. So let's take a look at a theorem that we're going to need to know for the rest of this unit. The sum of the measures of the angles of a triangle is 180 degrees. So the 3 of the angles in the triangle need to add up to 180 degrees, which is easy to remember because that's the degree of a line. So let's take a look at this triangle down here, triangle ABC. I have one angle that's 100, one that's 25, and one that's X. First, let's name that triangle. So I'm going to draw a triangle symbol, and I'm going to name it by its vertices, which is A, B, and C. Next, we want to talk about the classification of the triangle. Well, I see that it has an angle that is 100 degrees. Well, that's obtuse. That's greater than 90 degrees. So this has to be an obtuse triangle. And now we want to know what x is. So the sum of our angles has to be equal to 180. So 25 plus 100 plus that x angle has to be equal to 180. So then we have 125 plus x is equal to 180. So then we would subtract 125 from both sides. And we get that x is equal to 55. So by x equaling 55, all of the angles in our triangle will add up to 180. Let's take a look at this one. Triangle angle sum corollaries. The acute angles of a right triangle are complementary. So what does that mean? So if the measure of angle C is 90 degrees, then that means that this measure we'll call that x, and this measure we'll call that y. So that means that x and y also have to equal 90 degrees. Okay, so the other two angles then have to add up to 90 degrees. Remember, complementary means that they add up to 90 degrees. Let's take a look at this next one here. So we're going to kind of go through and we're going to fill out whatever we can. First thing I want you to point out is when you have a rectangle, all of these angles have to be right angles. So each of those squares are 90 degrees. So the first question asks us, what type of triangle is DGK? Well, instantly I see that DGK has a right angle in it, so then that makes it a right triangle. What type of triangle is GKF? Well, I see I have a small angle here, and both these angles have to be less than 90 degrees because they're not in the full corner. So then that triangle has to be acute because all of my angles are acute. They're less than 90 degrees. Find the measure of DGK. Well, here we have three angles already in our triangle. So to find DGK, I have 90 plus 40, and I don't know the measure of that angle, so I'm going to call it x. And that has to add up to 180. So to save some time, I'm going to assume that you can solve that equation on your own. So you add all of those up, and you end up getting 50 degrees. So if you were to take 90 plus 40 plus 50, it should add up to 180 degrees. Next, it asks us for the measure of angle EKE. Whoa. Oops, sorry about that. All right, EKF. So it's asking us for that measure. So I notice that this angle right here, plus this angle all make a line, that line DE. So then I know that 40 plus 65 plus, we'll call it y, whatever DKF is, has to be 180. So again, solve that for y, you end up getting 75. Let's take a look at the next one. It says find the measure of KGF. KGF. Well, remember we found this angle to be 50 degrees. And then we need to know this angle. Well, remember I said that this corner has to be a right angle. So that means that that 50 degrees, and we'll call this Z, plus our Z for KJF have to add up to 90 degrees. Again, I'm going to assume you can solve that for K, and that's going to give you 40. Last but not least, finding the angle measure of KFG. KFG. Well, we know that this guy is 40 now. We know that this is 65, and now we just need to find, we'll call it M. So because those are the three angles in the triangle, I can confidently say that these three things need to add up to 180 because they form a triangle. So I'm going to assume you can add those up, and then you get 70 here. Okay, next, let's take a look at this theorem here. Let's take a look at this problem. So the measure of angle 1 is 55 degrees. So that's 55 degrees. How do I know that's 55 degrees? Well, I know that 85 plus 40 plus, x has to be equal to 180. Okay, so solving that for x, that's how you get 55. Well, here I notice that 1 and 2 are vertical angles. So 2 also has to be 55. Last but not least, find the measure of angle 3. Well, we have 2 of the 3 angles in the triangle. So 55 plus 55, and then whatever our angle 3 is, has to be equal to 180. Solve that for y, and you will get 70 for that third angle. Let's take a look at this next part. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So angle 1, so the measure of angle B right here and the measure of angle A need to add up to the measure of angle 1. Okay, another thing we know, the measure of angle C, or this guy right here, and 1, well, they make a line, so they need to add up to 180. Okay, now let's take a look at this next one. So find the value of x. Well, we know that 50 plus x needs to be equal to 2x minus 15. Well, how do we know that? The sum of these two angles needs to be equal to that exterior angle. That's what that theorem tells us. So now we're going to go ahead and solve this for x. So I'm going to subtract x from both sides, and then I have 50 is equal to x minus 15. Add 15 to both sides, and I get that x is equal to 65. And then it asks us to find the measure of angle SMB. So I know that this guy right here is going to be 2 times 65 minus 15. Okay, then that plus this angle, we'll call it y, needs to add up to 180 because these guys right here form a line. So 2 times 65 is going to give me 130 minus 15 plus y is equal to 180. And then add those two together. We get y is equal to 115, or y plus 115, sorry, is equal to 180. Subtract 115 from both sides, and we get 65. So that right there is also 65. Okay? All right, next, I'm going to actually stop the video here, and I'm going to continue that last sheet of paper on a brand new video. Okay, so once you're done, just move on to the next video just so I can fit it on YouTube, okay?